So let's go ahead and call definition 6.1. We'll call this LU factorization without pivoting. So we're going to let A be n by n, be a given, and my mind is shot right now. Did we talk about regular matrices?
Yeah.
We did. Awesome, Mike. Thank you. And the whole idea of regular matrices, anybody remember that? Okay, well, you do. I can guarantee you do. It's just off the top of your head. It's been, how long has it been? Like, it's been a good 7-9 days, something like that, right? Do you remember what we said about these operations?
Yeah.
What type of matrices were these allowed to be? Shear, dilation, transposition. And we call those elementary matrices, right? Do you remember what the first strategy was when we were trying to get A into upper triangular form? The first thing that we did? Choose the 1, 1 element, call that pivot number 1, cancel out everything below the 1, 1 element. So literally we're going to get rid of all the sub-diagonal elements in column 1. Once that's done, we jump to column 2, choose the 2, 2 element, call that pivot 2, get everything done in column 2. Then we go down to the 3, 3, everything done. Every once in a while, when we're processing a matrix, as we eliminate everything under the 1, 1 pivot, the 2, 2 element may become 0. In the case that the 2, 2 element becomes 0, in order to choose a pivot, we actually have to transpose, we have to flip rows. Matrices whose pivots are non-zero without transpositions, we will call regular. Another way to say that is, a matrix is regular if it can be put into upper triangular form using only shear matrices. Right? So that all the diagonal elements are non-zero by only canceling out subdiagonal elements. Yep.
Is there a specific reason to call regular?
I actually don't like that language. I'm borrowing it from Oliver and Shakiman. They've done some good work. If you want a trainer's purpose, regular matrices are a lot easier to get your head around LU factorization. LU factorization is an introduction to what they call the partial pivoting algorithm. At some point in my future, I think 2030 is my goal for my first publication on this. I'd like to take some time to incubate on it. I will probably come up with a better word for that. I don't have one right now. Yeah, so no, because Oliver said so, or Shakiban said so. They said the wife said it. It's a good relationship, she said it, right? All right, so in a given regular matrix, so with all non-zero diagonal elements. Diagonal elements. And LU factorization of A is given by A equals L times U. With, can you guess what we say about U? What structure does it have? It's upper triangular. Not only is it upper triangular, but what else? Ooh. I want A to be a given regular and invertible matrix. What does it mean to be invertible? What doesn't it mean to be invertible, right? Yeah. What does it mean to be invertible again? A lot of stuff. inverse exists, columns are linearly independent. If you have an upper triangular matrix, what's one way that you can really, really quickly tell if an upper triangular matrix is not invertible? The diagonals are non-zero. You got it. Okay. So we've got a matrix A, we've got a lower triangular matrix times an upper triangular matrix. We say that the matrix U is an upper triangular matrix with all diagonals non-zero. And we'll say that L is unit lower triangular. Anybody remember what that was from lesson 8? It's been a while, huh? That's true. All your other classes, God, your other teachers are just so unfair, right? They should have stopped their classes when I got sick. Unit lower triangular means that all the main diagonal elements are 1.